Hi everybody, it's Mrs. Dunn. We're starting a new chapter today. What we're going to be learning today is how to solve a system of equations in two variables. We're going to do that by graphing, then we're going to use substitution and elimination. So let's get started. First, what I want to do is a brief overview of what we're looking at. If we're going to be solving a system of equations, this is an example of a system that we might solve. The solution set is the set of ordered pairs that makes both of the equations true. There's an infinite number of ordered pairs that makes the first equation true, and same for the second. But the solution set is the ordered pair or ordered pairs that work in both equations. The first thing we're going to do is solve that by graphing, and I'd like you to see the graph of this. So you'll see the graph of x minus y equals 5 is in blue, and 2x plus y is equal to 1 is graphed in red. And the solution set is that set of that point of intersection. And so the solution set is 2, -3. So what exactly could happen? We looked at one example where we got one solution to the system of equations. But what could happen is when we graph those lines, they might never meet. And when we graph them, we might actually end up with the same line. In the first example, which is what we saw on the previous screen, the lines intersect once, and there is one ordered pair that is the solution. We say this system is consistent and independent. When the lines do not meet, they do not intersect, there is no solution. We say this system is inconsistent and independent. And when the lines are exactly the same, there are an infinite number of solutions. And we say that this system is consistent and the equations are dependent. Okay, so going back to our original example, we're going to solve this system three ways: by graphing it, by using substitution, by elimination. So you actually already saw the graphing. You saw the graph. And then you can use the second calc intersect function to find the point of intersection. And the point of intersection is 2, -3. And that's the solution. Now let's solve this equation using substitution. To use substitution, I want to solve one of these equations for one of the variables. So for example, I'm going to use the first equation and I'm going to solve it for x. So when I rewrite this equation, x is equal to 5 plus y. I just added y to both sides of the equation. Now I'm going to take that substitution and substitute for x in the other equation. Well, the other equation was 2x plus y equals 1. And where there is an x, I'm going to put 5 plus y. I'm substituting for x. And then I just have to solve that equation. So I distributed 2, combine like terms, subtract 10, and divided by 3. And you notice I get y is equal to -3. Now you're going to have to go back and substitute that into the other equation. So I'm going to substitute -3, and I get 2x plus -3 equals 1. Solving for x, I get x is equal to 2. Remember, we already knew that was the solution. We saw it on the graph. Now let's look at how we do that using elimination. When you use elimination, what you actually want to do is you want to add these two equations together. And you want one of the variables to drop out. So if I add these two variables together, -y plus y will be 0. So I get x plus 2x is 3x, 5 plus 1 is 6, so 3x is equal to 6. Solve for x equals 2. Now, just like the previous screen, we're going to plug 2 in for x in the other equation. So when I plug 2 in for x, I end up with 2 times 2 plus y is equal to 1. And then I'll just solve this equation for y. 4 plus y equals 1, so y is equal to -3. And the solution is 2, -3, just like we had before. Now let's go through some more examples. So in the next example, you're going to solve this by any method. When I look at this, because of the way it's set up, I'm going to solve this using elimination. So to make one of these variables have opposite coefficients, it looks like the easiest would be the x terms. So what I want to do is I want to multiply the first equation by a -6. So when I do that, I get -6x plus 18y equals -12, multiplied every term by -6. The bottom equation didn't change. Now, when I add these together, the x terms are going to cancel, and I end up with 23y is equal to -46, which means y is equal to -2. Now, I'm going to go back to our equations. I picked the top one, but it doesn't really matter. And I'm going to plug -2 in for y and solve that equation. And I get that x is equal to -4. So the solution to this system is -4, -2. Okay, let's look at another example. So I have y equals 3x plus 2 and 3x minus y equals -3. Because of the way it's set up, I'm going to use substitution for this one. So because of the first equation is already set equal to y, I'm going to substitute this expression for y in the second equation. So when I plug in 3x plus 2 for y, you're going to notice that the 3x's are going to cancel. And we're left with -2 is equal to -3. Well, that doesn't make any sense. There's no variables left, and -2 isn't equal to -3. So this system has no solution. All right, one more example. In this next example, once again, you can use any method. I like elimination here because of the way it's set up. I think it's going to be easier to make one of these coefficients be opposites of each other. So one way I can do that is I can multiply the top equation by -2 and the bottom equation by 3. That's going to make my lead coefficients be -12 and +12 for x. So I did that here. Now, when I add these two equations together, I end up with 0 equals 0. So once again, those variables, they were eliminated, but the expression that is left is true. That's why there are an infinite number of solutions for this system of equations. So what we have to do, this might be new to you, but we have to solve either equation for x. So I'm going to take this 6x plus 9y equals 12. That's the top equation. I'm going to solve for x. And I get that x is equal to -9y plus 12 divided by 6. So the solutions to my system are any number that is generated by this formula. And the formula is the x value will be -9 times y plus 12 over 6. And the y value can be anything. So for example, if I say let's let y equal 1, and I plug 1 into this formula, I get the value of 1/2 for x. Go ahead and verify that. If you plug 1 in for x and 1/2 in for y, oh, I switched those. Let me fix. Okay, sorry, I went back a little bit. So when y is equal to 1, when I plug this into the formula, I get x is equal to 1/2. So when the ordered pair 1/2, 1, when x is 1/2 and y is 1 is plugged into either of these equations, they work. That's just one of the solutions. Remember, there's an infinite number, and this is like a formula that generates them all. All right, good luck.